Let us continue atomic structure. In this penetration power of orbitals, we will see. First, we will take 2s orbital. For 2s orbital, the curve is so and so. For 2s orbital, the graph is like this. That means here total probability increases, attains minimum maximum, decreases, attains nearly zero, rises, attains maximum maxima, and decreases and remains constant. It is for 2s orbital. Next for 2p orbital, the graph is like this. 2p orbital, the graph is like this. So now we will write, we will draw 2s as well as 2p. Both we will draw. How it will be that we will see. Now for 2s orbital, the graph is like this. It is for a 2s orbital. Next, for 2p orbital, we will draw the graph. For 2p orbital, this is for what means 2p orbital. For 2p orbital, the graph is like this. So, for 2s orbital and 2p orbital, we have given the graph. Now say that 2s electron cloud, 2s orbital electron cloud present 2s orbital electron cloud, how it is there means the total probability increases here, attains minimum maxima, then decreases, attains nearly zero, then increases, attains maximum maxima, and then decreases and remains constant. Like this 2s orbital is there. Then 2p orbital, electron total probability increases, attains maximum, and then decreases, remains constant. So 2s and 2p like this is there. Now near the nucleus, 2s electron cloud is present. 2s electron cloud is present near the nucleus. You see, near the nucleus means here 2s electron cloud is there. Okay. Then what about 2p electron cloud? Near the nucleus 2p electron cloud is present. Now see, this is 2p electron cloud is present near the nucleus. Sir. Now proportion we will see. Proportion of 2s electron cloud and 2p electron cloud we will see. Proportion of electron cloud near the nucleus, that if you see 2s and 2p, which is high, which is low, that we have to see. Okay. Now 2s, now we will take this distance. At this distance 2p electron cloud total probability is this much near the nucleus. 2s electron cloud total probability is this much near the nucleus. So near the nucleus, which is having higher total probability, that is 2p as low. So proportion of electron cloud near the nucleus, if you see, 2s is having higher value, 2p is having lower value. Sir, now 2s electron cloud is penetrating towards the nucleus. Penetrating towards the nucleus. Penetration means moving towards. 2s electron cloud is moving towards the nucleus. Similarly, 2p electron cloud is penetrating towards the nucleus due to attraction. So 2p electron cloud is moving towards the nucleus. Near the nucleus, which is having higher proportion, that is 2s electron cloud, whereas 2p electron cloud is having lesser proportion. So which is having higher tendency to penetrate means 2s is having higher tendency to penetrate towards the nucleus when compared to 2p. So that which is having higher penetration power? 2s is having higher penetration power, whereas 2p is having lesser penetration power. So penetration power for 2s is high, for 2p is low. Both are having same principal quantum number. Subshells are different, orbitals are different. Penetration power we have to see for same principal quantum number, but same principal quantum number we have to see. Penetration power we have to see for same principal quantum number, but different orbitals we have to take. So penetration power means same principal quantum number should be there, but different orbital should be there. Now for s orbital, L is equal to 0. For p orbital, L is equal to 1. So we can say as azimuthal quantum number increases, penetration power what happens means decreases. So that's what we can see here. In this case, for 2s orbital case, for 2s orbital, penetration power is high because 2s electron cloud present near the nucleus to a higher proportion. For 2p orbital, penetration power is low because 2p electron cloud proportion near the nucleus is low. Therefore, 2s is having higher penetration power, 2p is having lesser penetration power. Okay. So 2s penetration power high, 2p penetration power low. Azimuthal quantum number for s is 0, azimuthal quantum number for p is 1. As azimuthal quantum number increases, penetration power decreases. Therefore, order of penetration power if we see 2s greater than 2p. Now we will take 3s, 3p, 3d we will take. So penetration power means first main point is principal quantum number should be same. Then only we have to go for comparing penetration power. Okay. So 3s, 3p, 3d means all have same principal quantum number, that is 3. Now we will see different subshells. Azimuthal quantum numbers we will take. Azimuthal quantum number for s subshell is 0, for p subshell is 1, for d subshell is 2. So azimuthal quantum number increases means penetration power decreases, we can say. Azimuthal quantum number increases means penetration power decreases, we can say. So 3s is greater than 3p is greater than 3d. It is the order of penetration power, we can say. Next we will go for energy of orbitals. So now we will see energy of orbitals. Energy of orbitals in hydrogen atom and hydrogen-like species. That will take. Okay. Now, how the energy of orbitals will be there? Okay. Energy of orbitals is directly proportional to principal quantum number. Energy of orbital is directly proportional to what means principal quantum number, we can say. Sir, if principal quantum number increases, we can say energy of orbital also increases. Principal quantum number increases means energy of orbital increases. That's what we came to know. First, for Niels Bohr model, first shell means first orbit means minus 13.6, second orbit means minus 3.4, third orbit means minus 1.5. That means that's what we have seen in Niels Bohr. So Niels Bohr model, what we have seen means for first orbit minus 13.6 electron volt is the energy. For second orbit, energy is equal to minus 3.4 electron volt. For third orbit, energy is equal to minus 1.5 electron volt. Therefore, as principal quantum number increases, energy what happens means increases. So the same point is taken even in modern atomic theory, quantum mechanics. So energy of orbital is directly proportional to principal quantum number. As principal quantum number increases, energy of orbital also increases. Sir. Now we will take a first shell. First shell contains only one orbital, that is 1s. Next we will take second shell. Second shell contains 2s and 2p. Now we will see the energy of these. This 1s is having principal quantum number 1. This 2s and 2p having principal quantum number 2. Principal quantum number increases means energy also increases. Therefore, here energy is less, here energy is high. Therefore, 1s and 2s if you see, which is having more energy means 2s is having more energy, 1s is having less energy. Then 1s and 2p if you see, 2p is having higher energy, 1s is having lower energy. Like this is said. Then we will take a third shell. Third shell contains 3 subshells. One is 3s, another one is 3p, next one is 3d. For this case, what is the principal quantum number means 3. Now, out of these, this is having higher principal quantum number, therefore it is having higher energy when compared to these two. So 3s and 2s if you see, higher energy is for 3s when compared to 2s. 2s and 1s if you see, 2s is having higher energy than 1s. Next, fourth shell we will take. Fourth shell contains 4 subshells, that is 4s, 4p, 4d, 4f. For this, principal quantum number is 4. Now here, for the out of this, 4 is having higher value when compared to others. Therefore, this fourth is having higher energy when compared to this. So energy if you see, 4s is high, 3s less, 2s still less, 1s still less. Therefore, how the energy will be there means if we go, energy increases like this. So 1s is having lower value, 2s is having higher value, 3s is having still higher value, 4s is having a still higher value. Set. So how the energy of orbitals is there for a hydrogen and hydrogen like species, that we got an idea. Okay, hydrogen and hydrogen like species. Okay, now we will see 2s and 2p. 2s is having principal quantum number 2, 2p is having principal quantum number 2, both are having same principal quantum number. So energy of 2s is equal to energy of 2p. Both are having same principal quantum number, therefore principal quantum number is same, therefore energy is same. So energy of 2s is equal to energy of 2p, for which one means for hydrogen atom and hydrogen like species. Next, here if you see 3s, 3p, 3d, all these three have principal quantum number 3. All are having principal quantum number 3. So energy of 3s is equal to energy of 3p is equal to energy of 3d, we can say. This is possible for hydrogen atom and hydrogen like species. Now if you see here, in this case, all these subshells are having same principal quantum number. So all these subshells have a same energy. So energy of 4s equal to energy of 4p, which is equal to energy of 4d, which is equal to energy of 4f. Okay, therefore if principal quantum number is same, energy also same for hydrogen atom and hydrogen like species. So remember that for hydrogen atom and hydrogen like species, energy depends on only principal quantum number but not azimuthal quantum number. Okay, so for hydrogen atom and hydrogen like species, energy depends only on principal quantum number. Therefore, energy of 2s and 2p, energy of 2s and 2p are equal. Okay, now we will take multi-electron atoms. Energy of electrons or energy of orbitals. Energy of orbitals in multi-electron atoms we will see. Multi-electron atoms. So in multi-electron atoms, how it will be there? So multi-electron atoms in the sense, multi-electron atoms in the sense, what are the things possible? Multi-electron atoms. In multi-electron atoms, how the energy of orbitals will be there, that we will see. Okay, so energy of orbital, depends on n plus L value. Energy of orbital depends on n plus L value. As n plus L value increases, energy of orbital also increases. Energy of orbital also increases. As n plus L value increases, energy of orbital also increases. N is called principal quantum number, L is called azimuthal quantum number, we can say. Now we will take 1s orbital. For 1s orbital, principal quantum number is 1. Principal quantum number is 1. Azimuthal quantum number for s subshell is 0. Therefore, n plus L value is 1. N plus L value is 1. Now we will take 2s orbital. For 2s orbital, principal quantum number is 2. Azimuthal quantum number for s orbital is 0. Therefore, n plus L value is 2. Sorry, 1s and 2s if you see, n plus L value for 2s is high when compared to 1s. Therefore, 2s is having higher energy, 1s is having lower energy, we can say. Next we will take 2p. For 2p, principal quantum number is 2. Azimuthal quantum number for p subshell is 1, therefore equal to 3. 3 is n plus L value. For 2p, n plus L value is higher than 2s, therefore 2p is having higher energy when compared to 2s. Next we will take 3s. For 3s, principal quantum number is 3. Azimuthal quantum number for s subshell is 0, therefore 3. Now 2p is having n plus L value 3. 3s is having n plus L value 3. Both are having same n plus L value. While how to say energy of orbital, that we'll see. If n plus L value of orbitals, if n plus L value of orbitals is same, then energy of orbital depends only on principal quantum number. As principal quantum number increases, energy of orbital also increases. Energy of orbital also increases. Okay, this point when we have to take means when n plus L value remains same. When n plus L value remains same, then you see the principal quantum number. Based on principal quantum number, we have to say the energy of orbital. As principal quantum number is high, energy of orbital also high. Now for 2p, principal quantum number is 2. For 3s, principal quantum number is 3. So for 3s, principal quantum number is high when compared to 2p. Therefore, energy of 3s is greater than energy of 2p. So how the energy is there means 1s is having lower value, higher value 2s, still higher value 2p, still higher value 3s. So how the energy of orbitals are there? Order of energy of orbitals. Order of energy of orbitals, if you see how it is there means 1s less than, 2s less than, 2p less than, 3s. Like this is said. Then if you see 3p, then we will take 3d and 4s. We will take 3d and 4s. We will take for 3d principal quantum number is 3. And then azimuthal quantum number for d subshell is 2. So n plus L value is 5. For 4s, principal quantum number is 4. For s subshell, principal azimuthal quantum number is 0. Therefore, it is 4. So n plus L value for 3d is high when compared to 4s. So 3d is having higher energy when compared to 4s. So we will get 4s less than 3d. 3d is having higher energy when compared to 4s. Why? Because for 3d, principal quantum number for 3d is 3. Azimuthal quantum number for d subshell is 2. So n plus L value is 5. Then 4s, if we take principal quantum number is 4. Azimuthal quantum number for s subshell is 0. So n plus L value is 4. So n plus L value is high for 3d when compared to 4s. So energy of 3d is greater than 4s, we can say. So energy of 3d is greater than 4s. Okay. Now we will see why the difference 2s and 2p is having energy difference. What is the reason? And 1s and 2s is having energy difference. What is the reason? That we will see. 1s to first we will see 1s and 2s. Why energy of 1s is less than 2s? Next we will see why energy of 2s is less than 2p. That we will see. Set. For which what are the facts we have to see? Now we will take 1s and we will take 2s. Why one energy of 1s and 2s are different? Energy of 1s and 2s are different. That point we will see. Okay. For which we will take radial distribution function graph. We will take here. We will take radial distance. Here we will take 4 pi r square psi square. We will take. Then for 2s orbital also, here nucleus. Here we will take radial distance. Here we will take 4 pi r square psi square. We will take. It is called total probability. Now we will see the graph. How the graph is there means for this one peak. For this, if you see 2 peaks, we will get. For this 2 peaks are there. Then maximum most probable location will see. Most probable location is at 0.529 angstrom for 1s. But for 2s at where means 2.6 angstrom. 2.6 angstrom. Most probable location. Sir, most probable location for 1s and 2s we will see. So most probable location for 1s and 2s we are seeing. How it is there, that we will compare. Now most probable location of location of 1s and 2s. For 1s at 0.529 angstrom, for 2s at 2.6 angstrom. That means it is most probable location is close to nucleus. Now most probable location is closer to 1s, but far away to 2s. Here this distance is how much, means 0.529 angstrom, but this distance is how much, means 2.6 angstrom. Most probable location is less for 1s, high for 2s. Most probable location. Here nucleus is attracting this electron, so how the attraction will be there here? So between nucleus and 1s electron cloud, then between nucleus and 2s electron cloud, attraction will see. Attraction is more for this with 1s, attraction is less for with 2s. Therefore energy of 1s is less and energy of 2s is high. Energy is high. Okay, that's what we have seen even in Niels Bohr model also. Okay, with we are starting with respect to nucleus, we are saying energy. Okay, so here attraction is more, therefore energy of 1s is less. Attraction is less, therefore energy of 2s is high. Sorry, okay. So with respect to most probable location we say, or we can say with respect to size also. Size, if you see, size of 1s, if you see, size of 1s is less, size of 2s is high. Why? Because 2s most probable location is at 2.6 angstrom from nucleus, but most probable location for 1s is at 0.529 angstrom from nucleus. Therefore 1s is closer, 2s is far away. So for 1s size is less, for 2s size is more. So if size is more, energy is more. Okay, so like this we can say. So why energy of 2s? Why energy of 2s is greater than that of 1s? Because size of 2s is greater than size of 1s. It is one reason. What is another reason? That we will see. We will go for another reason. Now we will take hydrogen atom. In a hydrogen atom, how many electrons are there? Means only one electron is there. Suppose that electron present in 1s. This 1s orbital is having one electron. Hydrogen atom is having one electron. That electron is present in 1s orbital. We will take. So now we will take, it is a nucleus of a hydrogen atom, and it is a 1s electron. 1s electron is present here. Between this nucleus and the electron, what is there? Means only attraction is there. Only attractive force is there. Now we will take a helium atom. Helium atom is having 2 electrons. Suppose the 2 electrons present in 1s orbital. Suppose 2 electrons present in 1s orbital we will take. So for helium nucleus we will take, and this 1s orbital is a spherical shape. That spherical shape we have drawn, and it is having 2 electrons. That 2 electrons will write one electron. Now between nucleus and the electron cloud, what is there? Means attraction is there. Now between this between nucleus and electron, what is there? Means attraction is there. Sorry, okay. Now we will say, now based on this attraction, we are saying here distance between these two is x. Here also, if only attraction is there, then distance between nucleus and this electron is x. Distance between the nucleus and the electron is x. There is no doubt. Only attraction is there. Means if we consider only attraction, then distance between nucleus and the electron is x, like this. Now, is there any other interaction possible? That we will see. Now it is a nucleus, and this is a 1s orbital. 1s orbital is spherical shape. 1s orbital is having 2 electrons here. In this helium, 2 electrons is there. Now between these 2 electrons, will there be any interaction? This electron and this electron is having same charge, so between them repulsion is possible. Due to repulsion, what will happen? They will go far away from each other. Okay, so due to repulsion, they are going far away from each other. Now that 2 electrons we have said, So now we will consider attraction as well as repulsion. Now we will see the distance. Now how this distance will be there when compared to this x. Here repulsion is possible, here repulsion is not there. Here we can say repulsion is possible between electrons, here repulsion is not possible. Due to repulsion, electrons are going far away. Therefore, how the distance will be there between nucleus and electron in this helium when compared to this hydrogen, if you see, this distance is more when compared to this one. So, due to that, what had happened? Due to that, what had happened means distance increases means what had happened means attraction decreases. Due to this repulsion, attraction decreased. Okay, so what we can say means due to repulsion between electrons, electrons go far away. Electrons go far away. Therefore, attraction between nucleus and electron decreases. Okay, and attraction between nucleus and electron decreases. That decrease in attraction between nucleus and electron is due to another electron. That means what we are saying means here, because of this electron is repelling this. Because of this electron goes far away from the nucleus. Therefore, attraction is decreased. Similarly, this electron is repelling this electron. Because of this right side electron, left side electron goes somewhat far away. Therefore, left side electron is getting somewhat less attraction from the nucleus due to right side electron. So now we can say, so decrease in attraction between nucleus and electron is due to another electron. Therefore, this another electron, we can say this another electron screen the nucleus. This is we will say number 2, we will say it is number 1, we will say. This another electron means the second electron screen the nucleus to show less attraction with the first electron. Therefore, this effect is called what means screening effect. This effect we can call it as a screening effect, or we can call shielding effect. Now you say, this shielding effect, is it possible? This shielding effect, is it possible for hydrogen and hydrogen-like species? No. Why? For hydrogen and hydrogen-like species, screening effect is not possible since only one electron is there. Then how screening effect is possible? Since only one electron is there, therefore how screening effect is possible? Screening effect is not possible for hydrogen and hydrogen-like species. For multi-electron atoms, if you take, screening effect is possible. Multi-electron atoms means 2 electrons or more than 2. So because of this screening, what will happen, that we'll see. So because of screening, this left side electron screen the nucleus to have less attraction with this right side electron. This right side electron screen the nucleus to have less attraction with the left side electron. That means this left side electron shows screening effect over right side electron. Right side electron shows screening effect over left side electron. So screening effect, due to screening effect, what happens between nucleus and electron? Attraction decreases. Said okay. Now we will see this oneness. For oneness, energy is less. For 2s, energy is high. Now we will see oneness and 2s, between them is there any screening or not, that we will see. 1s is having lower energy, 2s is having higher energy. 1 we said with respect to size we said. Now what about screening effect? Screening effect, will it be present or not? That we will see. And we will see in terms of screening effect we will see. So now we will take 1s. For 1s, suppose we will take helium. Helium in the sense nucleus we will take, and it is having 2 electrons. This helium is having 2 electrons. Okay, helium is having 2 electrons. The 2 electrons let us write in 1s orbital. So 1s orbital we have given. Here what is there means screening effect is there or not means no doubt screening effect is there. Screening effect is present here. Okay. Now we will take a lithium atom. Lithium atom is having 3 electrons. Let us distribute 3 electrons in what way means 2 electrons we will give to 1s orbital, and 1 electron we will give to 2s orbital we will give for lithium. Now we will take a lithium nucleus we will take. In lithium, the 1s orbital is having 2 electrons, and 2s orbital is having 1 electron. 2s orbital is having 1 electron. So now we will see regarding repulsion, we will see how the repulsion will be there, that we will see. This 1s electron is repelling this 2s electron. This 1s electron is repelling this 2s electron. Repelling this 2s electron. So now we can say this is what means 2s electron. This is what means 1s electron. This is what means 1s electron. So 2s electron gets repulsion from 2 1s electrons. 2 1s electrons. Whereas here we will see it is 1s electron, it is 1s electron. 1s electron gets repulsion from another 1s electron. Here in this case what happens? 2s electron gets repulsion from 2 1s electrons. Here 1s electron gets repulsion from another 1s electron. So how the repulsion magnitude will be there? So we can say that what is the conclusive statement we can say means 2s electron gets higher magnitude of repulsion due to 1s. But here we can say in this case 1s electron gets lesser magnitude of repulsion. 1s electron gets lesser magnitude of repulsion from another 1s electron. We can say. So that this 1s electron gets lower magnitude of repulsion from another 1s electron. 2s electron gets a higher magnitude of repulsion due to 1s. Therefore, which is getting higher screening effect? In the sense 2s gets a higher screening effect when compared to 1s. So from this, what is the conclusion we can say? So 2s gets a higher screening effect. 2s gets a higher screening effect due to 1s. But 1s gets a lower screening effect due to another 1s electron. We can say. So screening effect order, if you see this 2s gets a higher screening effect because of 1s, but 1s electron gets a lower screening effect due to another 1s electron. So that in the screening manner, if you see where screening effect is more in the sense 2s gets a higher magnitude of screening effect, whereas 1s gets a lower magnitude of screening effect. So that we can say this 2s is getting a higher screening effect. We can say 2s is getting higher screening effect, but 1s gets lower screening effect. 1s gets a lower screening effect. We can say 1s is getting lower screening effect. So screening effect is low means getting lower screening effect means between nucleus and electron, between nucleus and 1s, higher attraction. 2s is getting higher screening effect means higher repulsion. Higher screening effect means higher repulsion it is getting. Therefore, between nucleus and 2s, attraction is low. Attraction is low means energy will be high. So energy of 2s is high, whereas energy of 1s is low. So what is the conclusion here in the sense energy of 1s is less than energy of 2s. So what is the reason in the sense one reason is due to size, another reason is due to screening effect. Another reason you can say due to screening effect we can say. So next we will see regarding 2s and 2p we will take. So energy of 2s is less than energy of 2p. What is the reason we will see. So how it will be there, that point we will see. Okay, now we will take suppose beryllium we are taking. Beryllium atomic number is 4. So beryllium is having 4 electrons. Let us distribute 2 electrons in 1s, another 2 electrons in 2s we will take. So next we will take what means suppose boron atom we are taking. It is having 5 electrons. First 2 electrons we will give to 1s. Next 2 electrons we will give to 2s. Next 1 electron we will give to 2p. Now this 2s, this 2s is getting screening effect due to 1s. Okay, this 2s orbital, this 2s orbital gets screening due to 1s. Now we will see regarding this 2p. This 2p will see this 2p. Okay, this 2p gets screening due to 1s and 2s. Therefore, which is having higher screening effect, which is getting higher screening effect, which gets higher screening effect, that we will see. So this gets lower screening effect. This gets lower screening effect. This gets higher screening effect. Okay, this gets higher screening effect. Screening effect is high means attraction between nucleus and respective is less. Therefore, energy is more. So this energy is more. This energy is less. Because screening effect is low. Screening effect is low means gets lesser repulsion. Gets a lesser repulsion means attraction with the nucleus is high. Therefore, energy is less. Energy is more. And another point we have seen that penetration power. Penetration power for 2s is high. Penetration power for 2p is low we have seen. Penetration power means moving towards nucleus. Now here this penetration power is more means proportion of 2s electron. Proportion of 2s electron near the nucleus. Near the nucleus if you see high. Here proportion of 2p electron. Proportion of 2p electron near the nucleus if you see